Hey guys, hope you have your notes ready. We're going to start this new section on similar triangles, specifically similar right triangles, by doing a little bit of background. And so we're going to review simplifying radicals. This is something that we've already done once this year in geometry and something that you did in Algebra 1 as well. So on your notes, if you'll just kind of follow along, it says most of the radicals you will work with in geometry will be square roots. That means that there is an understood 2 on the radical, and that 2 would go right here. It's called an index. What this 2 means is that you can take out factors of numbers under the radical when they happen in pairs. Factors that happen in pairs. Now you can factor by hand with something like a factor tree or whatever method that you use to factor. Or you could factor in the calculator, and those buttons are menu and the menu button. If you're looking at your calculator, we've got our Inspires. Turn that on, of course. So menu is right there underneath doc. And then option number 2 is number. And then after number, you're going to choose option number 3, which is factor. Menu, number, and factor, or menu 2, 3. And you can just type the 2 and the 3. You don't have to use the cursor keys. So now that we have figured out how to factor, we're going to simplify the following. And again, this is just review. I know that we've done this before. So I just wanted to jog your memory before we start using factoring and simplifying radicals in a different context. So what we're going to do is we're going to simplify square root of 98. So probably the way you're going to do it's going to be in your calculator. So when you do menu number factor, it pops up just like this. It says factor and it has these parentheses. And so we're going to type this radicand in here. So the radicand is the number under the radical. So I'm going to factor 96. And it says 2 to the 5th times 3. So that means there are 5 2's. So I'm just going to rewrite this square root of 96 as 1, 2, 3, 4, 5 2's followed by a 3. So 5 2's and a 3. Now, according to our notes, it says that we can take out these factors in pairs. So what we're actually doing is we're grouping into perfect square factors. So 2 times 2, this is 4. And when I take the square root of that, it comes out as 2. Well, here's another 2 times 2. So that's another 4. And the square root of 4 is 2. And then I just have this 2 and this 3 left over. They don't have any pairs that they can come out with, so they just have to stay under. We're going to multiply everything that comes out. So 2 times 2 comes out, which means 4. And then underneath the radical, we have 2 times 3, which is 6. So the simplified version of the square root of 96 is 4 square root 6. Let's do the same thing with 88. So I'm going to give you a chance to do menu number factor and factor 88. And your calculator should tell you that that is 2 cubed times 11. So 1, 2, 3 2's, right? 2 times 2 is 4 times 2 is 8. And then 8 times 11 gives us 88. Look for groups of factors, pairs of factors rather. See what you can take out. In this particular section, you should only have, or this particular list of factors, you should only have this single pair, right? 2 times 2 is 4. The square root of 4 is 2. And then you don't have any other pairs left. So you have 2 square root 22 as the simplified version of square root of 88. Next, we have 124. So again, go ahead and do menu number factor if that's how you're planning on doing this. This is 2 squared, so there's 2 2's, times 31, right? And this is just what your calculator is telling you, right? 2 squared means 2 2's and the 31. That's where I'm getting these numbers. Look for any groups, any pairs of 2 that you have. I do have a single pair. 2 times 2 is 4, and the square root of 4 is 2. So this 2 gets to come out, and the square root of 31 is what's left over. So the square root of 124 is equal to 2 square root 31. Been using a lot of 2's. 135 is not going to have any factors that are 2. So go ahead and factor. List your factors out. This one says 3 cubed times 5. So when I rewrite 135, 3 times 3 times 3 times 5. Look for pairs and circle them. I see a pair right here, pair of 3's. 3 times 3 is 9. And when I take the square root of 9, the radical drops off and it's just a 3. So this 3 gets to come out. And then under the radical, we still have a 3 times a 5, which of course is 15. And that is how you simplify radicals. Okay, steps again, you're going to factor the number underneath the radical. That's called the radicand, but you're going to factor it no matter what it's called. If you get it down into its prime factors like we have here, you're going to look for pairs, because remember, outside each of these square roots is this understood 2. And so this means that my factors need 2 in a pair to come out. So here is a pair of 2's. 2 times 2 is 4. Square root of 4 is 2. Here's a pair of 2's. 2 times 2 is 4. Square root of 2, right? So we just do that all the way through. Anything that gets to come out, if you have multiple factors that get to come out, you multiply those together. So the product of 2 and 2 is where I got this 4. And then anything that stays under, like this 2 and this 3, you multiply those back together also, and you get 6 in this case. Over here, this 3 and 5, they got multiplied back together to make 15. So there are your steps for simplifying radicals. You have an IXL on simplifying radicals. And you need to get to a SMART score of 80, as usual, on this IXL. That will be linked to your Google Class post for today. You'll also have another assignment. We're not just simplifying radicals. We're talking about how to solve for some specific pieces of some specific triangles. And in doing that, we're going to have to use what's called the geometric mean. So if you'll flip your paper over, geometric mean is probably not something that you did in Algebra 1. It's probably not something that you have ever heard of before. You might remember that mean, if we were talking about like middle school math, this was just another word for the average. And the geometric mean is kind of like an average, but geometric in this case doesn't mean having to do with shapes. It means having to do with multiplication. You might remember arithmetic and geometric sequences. An arithmetic sequence is where you add the same number over and over and over. So perhaps you add 3 every time. And so you might start with 1, and then you add 3 and you get 4. You add 3 more, that's 7. You add 3 more, you get 10. That's an arithmetic sequence. A geometric sequence is where you're multiplying. So let's say that instead of adding 3, you're going to multiply times 3. So I'm going to take this 4, and I'm going to multiply times 3, and that would give me 12. And then I'm going to multiply times 3 again. 12 times 3 is 36. And then I'm going to take that 36, oops, and I'm going to sling my pen. I'm going to take that 36 and I'm going to multiply times 3 again, and that's going to give me 108. And we could keep going with this. Let's just do a couple more. 108 times 3 is 324. And then 324 times 3, this will be our last one, is 972. I just realized you might not have been able to see all of that. I apologize. So here is a geometric sequence. It's just a list of terms, a sequence of terms, where you are multiplying by the same amount every time to get the next term. And so the geometric mean is what's in the middle. So if I were to say, what's the geometric mean of 4 and 36? Well, the number in the middle of that is 12. Or what's the geometric mean of 4 and 324? Well, as I jump toward the center, 36 would be the mean, because it's exactly in the middle of that list of numbers where you're multiplying by the same thing every time to get the next term in the sequence, right? So the geometric mean between 108 and 972 is just 324. Or the geometric mean between 12 and 108. Well, between 12 and 108 would be 36. Or between 12 and 972, right? You have, these are the ends, jump in, 108 is the geometric mean between 12 and 972. And so that's in general what it is. It's this list of sequences where you have the same number being multiplied every time to get the next sequence, and the geometric mean is the middle of that. And you might be wondering, well, am I going to have to like make this list for every problem that I do? And the good news is no. The way that we find this without listing out the actual sequence is that the geometric mean is the square root of the product of two numbers. Okay, so the square root of the product of two numbers. So let's use this sequence that we've got up here to kind of test this out and see how that actually works. So let's use 4 and 36. That was a pretty easy one. So if we're going to say 4 and 36 and we want the geometric mean, we're going to multiply them and take the square root. So let's multiply 4 and 36. It's going to get our calculator out over here. So 4 times 36 is going to be 144. And the square root of 144 is, of course, 12. That's exactly what we had in our list. Let's try some that are farther apart. Let's try 12 and 972. Let's find the geometric mean, which means we are going to take a square root and then multiply two things. The geometric mean of 12 and 972. All right, so this is going to be a really, really big number. So what I'm going to do is I'm actually going to go ahead and say to factor, oops, thought I was anyway. There it is. I'm going to factor 12 times 972. Okay, so not a huge list. 2 to the 4th times 3 to the 6th. So 4 2s, 1, 2, 3, 4. And then 6 3s. 1, 2, 3, 4, 5, 6. Just barely fit. Okay, here's a pair that gets to come out as a 2. Here's a pair that gets to come out as a 2. Here's a pair that comes out as a 3. It's another pair of 3s and another pair of 3s. So that means there's nothing left under our radical because everything had a pair. So we're just going to multiply the numbers that come out. We have 2 times 2 and 3 times 3 times 3. Okay, now you can do those however you want to. If you want to type them in your calculator, that's fine. I'm going to do 2 times 3, which is 6. And then 2 times 3, which is another 6. And so those two 6s are going to make 36. And then 36 times 3 is 108. And as you can see, that's exactly what it's supposed to be. The geometric mean of 12 and 972, which again is the geometric mean is just the number that's in the middle in this sequence. The number that's in the middle of 12 and 972 is 108, just like we calculated. So what this allows us to do is it allows us to find the geometric mean of other numbers where we don't necessarily have the sequence. We don't have this list up here that we can just refer to. We don't even necessarily know what they're multiplying by every time, but that's okay. We don't have to know because this little formula up here where we multiply and then take the square root, it takes care of all that. So what we're going to do is we're going to find the geometric mean of 4 and 9. So whenever you see find the geometric mean of, I want you to go ahead and set up a square root and a times. Now I tend to put a dot. You'll see why here in a little bit. But if you want to put an X, just make sure that it looks like the little times symbol and not like the letter X. So we're going to multiply the two numbers. 4 times 9, well, that's of course 36. And the square root of 36 is just 6. So the geometric mean of 4 and 9 is 6. Let's do 6 and 12. Geometric mean of 6 and 12, we set it up. That's the geometric mean of 6 and 12. Well, 6 times 12, 72. And if you're factoring in your calculator, you can factor, do menu number factor, and factor 72. It comes out to 2 cubed, which is, oops, I'm sorry, there's some 3's in there also. It's 2 cubed and 3 squared. So I'm going to go ahead and do the 3 since I accidentally wrote that first. There's the 3 squared, and then 2 cubed is right there. Okay, same thing that we've been doing. Let's look for our pairs to take out. 3 times 3 is 9. That comes out as a 3. 2 times 2 is 4. That comes out as a 2. And as you can see, this is going to be dependent on your ability to simplify radicals, because to find the square root of 6 times 12, you're going to have to be able to simplify. Okay, so 3 times 2 gets to come out, and this 2, I kind of wrote on him, he has to stay under. So 6 square root 2 is the geometric mean of 6 and 12. Okay, I'm going to give you a minute to set up and to solve the geometric mean of 14 and 12. So the first thing you want to do is make sure you've put these under the radical correctly. You can factor it in your calculator from here. You don't have to multiply. You don't have to multiply first. Let me say that. You don't have to put these together and get a really big number and then break down the big number. You can let your calculator do the heavy lifting on that. So this is 2 cubed times 3 times 7. There's our 2 cubed times 3 times 7. Only one little set of numbers gets to come out. So I'm going to give you a second to write the simplified answer. Remember, whatever is out here, this gets to come out of the radical, and then whatever's under here has to multiply back together. So I hope that gave you a couple of seconds to write 2 square root 42 over here. The 42 came from 7 times 3 times 2, in whatever order you want to. And then the 2 was the only thing that got to come out. Okay, so you won't always just have whole numbers. You can do these geometric sequences, geometric means with anything. So we have an example with a decimal, and then we have an example with some radicals. And just because it's, you got decimals and you got radicals doesn't mean that this is going to come out funky every time. So we're going to multiply 4.2 times 10. Because that's how we set up our geometric means. We multiply those two numbers together. And that is the square root of 42, which you might recognize from this earlier answer. And since the square root of 42 didn't simplify up here, it's also not going to simplify down here. So we're just actually going to leave that as the square root of 42. Sometimes they won't simplify very much. Sometimes they won't simplify at all. And then last, we have square root of 50 and square root of 2. So in order to kind of keep things organized here, I'm going to set up my geometric mean in a different color. So I'm taking the geometric mean of the square root of 50 and the square root of 2. It's a lot of square roots. It's okay, don't freak out. When you have two numbers that are under matching radicals, you can multiply those numbers together. So I'm going to leave this blue radical. This is from the geometric mean, right? These radicals are from my numbers that I was given. So 50 times 2 is 100. So now I can simplify the square root of 100. Don't lose this extra radical from your geometric mean, right? That's why I'm writing it in a different color, is I don't want us to get confused about A, where it came from, and B, when it goes away. So 50 times 2 is where I got this 100, and the square root of 100 is 10. If you factor 10, you're just going to get 2 and 5. So this is actually the finished answer, square root of 10. So the square root of 10 is the geometric mean of the square root of 50 and the square root of 2. And this is really all you're going to be doing for a lot of the triangle things. But sometimes you'll see some other questions as well. So notice the difference in how 6, 7, and 8 are phrased as compared to 5 and above. You're finding the geometric mean up here in all these 1 through 5. But in 6 through 8, it tells you what the geometric mean is. It says 8 is, 6 is the geometric mean, 12 is the geometric mean. In math, when you're setting up a word problem, is means equals. Okay, and then you're going to have the geometric mean, that's your square root with a times under it. So this is how all of these are set up in this section. And anytime you see this wording, this is going to be how it's set up. You're going to set up, like in number 6, 8 is or equals the geometric mean of 16 and what other number? Well, this what other number, this is just going to be a variable. We don't know what the number is, so we need to put a placeholder in there. So I'm just going to stick an X in there. 8 is or equals the geometric mean, square root with a times, of 16 and X, because X is the other number that we don't know yet. Now, I mentioned earlier that when I set up a geometric mean, I usually put a dot under here instead of an X. This is why. If you are putting an X under here as one of your unknowns, then you're probably going to want to make sure that it's really clear whether your X's are an unknown or whether you're multiplying some stuff together. So the best way that I have found to do that is to just put a dot here instead of an X. So how to solve this looks a lot scarier than it really is, I promise. We're going to square both sides, because when you square a square root, those two things cancel out. So 8 squared is 64, and that's equal to 16x. Then, of course, you divide by 16, and that gives us 4 equals x. So 8 is the geometric mean of 16 and 4. Let's do number 7. I'm going to give you a second to set it up. It'll set up just like number 6. Okay, so 6 is, which is 6 equals, because is means equals in math. The geometric mean, that's a radical with a multiplier underneath there. 6 is the geometric mean of 9 and some unknown number. So 9 and x. Once again, to solve, let's look back up at our previous example. If we're trying to get rid of this radical, we're trying to get x all by itself, right? So we're peeling away layers like an onion. We're going to square both sides, because this radical and this exponent of 2, they're going to cancel out. So 6 squared is 36. 9 times x can be rewritten as 9x. And then from there, just basic algebra that you're used to, right? We divide by 9 on both sides. And once again, same answer as before. 4 equals x. Lastly, we have number 8. 12 is, write this down, the geometric mean of 18 and some unknown number. Okay, write your problem down. 12 is the geometric mean of 18 and an unknown number. So you should have 12 equals the square root of 18 times x. Go ahead and start solving. I'm going to give you a second to see if you can get rid of that radical first on your own. Okay, so if you looked up at your previous examples, I hope you saw that we squared both sides. It's important to square both sides because the square and the square root are going to cancel. 12 squared is 144, and that now equals 18x. We divide by 18, and so 8 equals x. So that tells us that what we found, 12 is the geometric mean of 18 and 8. Just like up here, 6 was the geometric mean of 9 and 4. And 8 was the geometric mean of 16 and 4. Okay, so these are the only two things that you'll be asked to do with this, guys. You'll either be finding the geometric mean like we did in 1 through 5, where you have the two numbers, you just plug them in and you solve, you simplify really. Or you'll know the geometric mean and then you'll be finding a missing number. And in that case, you just take the geometric mean and that is or equals, and then you set up your geometric mean formula over there. All right, so for this one, you have an assignment that is on Quizzes. This will be linked to your Google class as well. There are a few of these, both ways. Some where you're finding the geometric mean and some where you're given the geometric mean and you're finding one of the other numbers. I think there's a total of about maybe 10 of these kinds of questions and then some random questions that are mixed in as well. So I will see you guys tomorrow. And I hope that you come in prepared with questions because my plan is for tomorrow, we're going to actually start using the geometric mean to find some missing sides of similar triangles. And this is very much a shortcut. So this is going to be a valuable thing to know. All right. Best of luck on your work. See you guys tomorrow.